Right, dear students, welcome back to this video series where we'll be looking at our A math worksheets. So for today, we'll be looking at coordinate geometry, right? The circles portion of the chapter. Okay, so in this video, I will only go through questions 2 and 3, right? I hope that it will provide sufficient hints for you to attempt the questions independently. All right, so questions 1, 4 and 5 are similar, right? So I hope that you'll be able to pick up some skills from these two questions to try out the remaining questions on your own. Okay, so without further ado, let's look at question 2. Okay, so for question 2, we are given that a circle C1 has a diameter, okay, AB, where A is the point 6 minus 2, and B is the point 12, 6. Okay, the first part of the equation, of the question, sorry, is simply asking us to find the coordinates of the center and the radius. Relatively simple question. Okay, so if we know that A and B are points on the circle such that AB is the diameter, right? Clearly, the center of the circle must be the midpoint of both points. Am I right? And that would be the center. Okay, so in order to find the center in this case, we'll simply apply the midpoint formula, right? And substitute the relevant values into the formula to find the center. That I will leave you to find it out yourself, okay? Next, how do I find the radius? Okay, so if I know AB is the diameter, the radius would simply be half of the diameter, isn't it? Right? So do I know the length of AB? Right? We do not know, but we know the coordinates of A and B. And that enables us to apply, right, the distance formula we have learnt in E-math to do that for us. So applying the distance formula, we'll be able to find the length of the diameter AB, and of course subsequently, right, we would want to divide the answer by 2 to find the radius. Okay, so that will be the first part, A. So let's look at the second part. The second part requires us to find the equation of C1. So C1 is basically this circle which they have mentioned and I've drawn over here, right? Just to recap, okay, the general form of the circle is of x minus a whole thing squared plus y minus b whole thing squared equals to r squared, where a and b would then be the center and the radius would just be r units. Okay, so if I have already found out what are the coordinates of the center and what's the radius, I can simply substitute back into this equation, right? And I will be able to find the general form of this circle. Okay, so I'm done with part B as well. Relatively simple, right? And for part C, okay, I want to show that the equation of the tangent to the circle at A is given by this formula, by this equation, sorry. So I've already sketched out the diagram, okay? So I encourage you to do so if you cannot visualize, okay? It need not be perfect, but at least, you know, when you sketch it out, you can see for yourself how it looks like. Okay, so the tangent at A would simply be this line over here, and we would like to show the equation of the tangent is given by 4y plus 3x equals to 10. So how do I do that? So recall that if you want to find the equation of a line, you need two things. You need gradient, okay, and you need any point. Okay, so you can have point A or point B, up to you. Okay, so in this case, you want it to be specifically point A. Okay, because the question is saying that the tangent is at A. So you don't have a choice. You have to use the coordinates of A in order to help you to find this equation of tangent. And what is the gradient of this tangent? So if you recall from E-math, we have this property, okay, tangent perpendicular radius. So in this case, we are able to easily deduce that this angle over here is 90 degrees. So recall that if we know the gradient AB, okay, if we know the gradient of AB, right, the gradient of tangent would simply be -1 over the gradient of AB, okay, because both are perpendicular to one another. Okay, so I'm going to apply the AMath method to find the equation of a line. So y minus y1 equals to mx minus x1. Okay, like I mentioned, because we are looking at the tangent at A, we require, okay, to sub in the y coordinates of A and the x coordinates of A, with of course your gradient of this tangent as well, which you have easily found over here. Okay, so that would be your answer. Of course, your answer should be in y equals mx plus c form, but what is m and c, I will leave it to you to find it out yourself. Okay, so the last part, right? The last part, they're asking us to do this. Okay, they're asking us to explain why 5,6 lie in only one of the circles. Okay, given another circle C2. Okay, so to answer this question, what I will do is, let me just to ask you a question. So if I'm given this arbitrary circle, so this any random circle, okay, if I were to tell you this point C lies in this circle with center O, okay, so what can you say about the length of OC relative to its radius? Okay, I think most of you should be able to tell me the correct answer, right? Of course, very clearly from the picture, if OC lies in the center, okay, its length would be lesser than that of the radius of this circle it is lying in. Okay, so I'm sure you should be able to use this method to, okay, check which circle does this point, okay, 5,6 lie in, whether it lies in C1 or C2. Okay, right? So that is your part D, right? So I'm done with question 2. Right, let me go to question 3 now. Okay, question 3. The equation of C1 is given by the equation, okay, 2x squared plus 2y squared minus 16x plus 4py equals to 22. Okay, what they are telling us also is that p is positive, right, and the radius of this circle C1 is 6 units. Okay, so what we are going to do is to determine the value of p and of course its center. Okay, so what I'm going to do is I'm going to first of all, okay, divide throughout the whole equation here by 2. Okay, and I would have gotten this equation. So I'm just trying to tidy up. Okay, so another reason why I divide by 2 is because I want the coefficient of x squared and y squared to be equals to 1. So later when I apply completing the square method, right, I will be able to just complete the square without having to factorize out any coefficients here. Okay, so the next step, okay, I would group all the x and y terms together, right? So that helps us to complete the square later. Next, right, I would apply completing the square, right? So I would have x minus 4 whole thing squared minus 4 squared plus y plus p squared minus p squared equals to 11. Okay, so you realize that these are your constants. Okay, throw them to the right side. Okay, group them together with 11, right? Then you should get this line over here. You should get this expression over here. Okay, so we are almost done, right? Recall the general form of the circle is given by x minus a squared plus y minus b squared equals to r squared. Okay, so in this case, your p squared plus 27 is actually equals to r squared. This is r squared, but I want r. So what should I do? Okay, so in order to have the r squared coming out, I have to determine r. And in order not to change the question, if I have a square over here, what I will need to do is to apply square root. So p squared plus 27. And when I square it, okay, it removes the square root, and I didn't change the question. Okay, so clearly from this equation, square root p squared plus 27 would be equals to your radius r. Okay, then recall the question told us the radius is 6. Okay, so clearly we would have this equation. Then after that, I will expect you to solve for p and determine whether what are the values of p. Okay, then of course, just by looking at this equation, I also know that the center is 4, negative p. Of course, if the moment you know p, you should substitute in. Okay, so for you should have the answer already, right? The answer for the center is just this 4, negative 3 over here. Okay, I'm just writing it out so because I'll be using it quite often for the next few parts. Okay, so I'm done with the first part. Okay, for part B, the question is asking whether the line passes through this center of C1. So they are referring to this point over here. Okay, so recall, if the line passes through the point, what happens? Okay, the point must satisfy the equation of the line that it passes through. Okay, so in order to show that it satisfies the equation of the line, I would want you to substitute the x coordinate into x and y into the left hand side. Okay, so you should present your answer as such. When x equals to 4, y equals to minus 3, right? So you should have 3 times 4 minus 3. And you should determine if this is equals to the right hand side, which is equals to 6 or not. Okay, so if it's equals to 6, it lines. If it's not equals to 6, okay, then of course the line does not pass through the point, or the point doesn't lie on the line. Okay, so that I let you to do it yourself. Okay, then after that, you should explain your answer in this manner. Okay, so that's part B. Part C, okay, they're saying that now this circle C1 is reflected in the line x equals to 3. So you should recall that this is a vertical line. Okay, then you want to find the equation of the reflected circle C2. Okay, so as we have found earlier in part A, the center of this circle C1 is 4, negative 3. So this is just a sketch. Okay, I've also drawn the line, the vertical line, in fact, with the equation x equals to 3. Okay, the question is asking you what is the equation of C2. So when you reflect this center, okay, the first thing you need to do is to tell me what is the new center of this reflected circle. Okay, will you be able to do that? Right? Notice that since this is a mirror, you can take this as a mirror. Okay, so this distance in blue should be equal to this distance. Okay, so what can you say about the x coordinates of C2? I'm sure you should be able to do it yourself, right? And you should be able to tell me that the y coordinate of C2 remains unchanged because it should be lying in the same line. Okay, so you should be able to find the center C2. Okay, this x and y I leave you to find yourself. Okay, then the next question is, when you do a reflection, will the size of the circle change? If the size of the circle does not change, what can you say about its radius? Will it remain the same? Will the length of the radius remain the same? Okay, so if you know the answer to my question, you should be able to find this equation. Okay, of course you can write it in this general form over here. So the equation of C2 should be looking something like that. Okay, so I'm going to the last part now, D. Okay, they want you to find the equation of another circle C3 which passes through the origin and has the same center as C1. So again, the same center as C1 refers to this point 4, -3, which we have found earlier. Okay, so if you can't visualize, what I will advise you to do is to sketch. So I've sketched the diagram. The center passes through the origin, okay, and it has the same center 4, -3. So this is the new circle C3. The question is asking you to find this equation. Okay, so if it passes through the origin, are you able to find the distance of this blue line segment? If you are, that would be the radius, isn't it? Okay, do you know the center? Yes, you know the center and you have the radius. Will you be able to find the equation of this circle? Right? Yes, you will be able to do that. Okay, you just substitute your relevant, right, coordinates and radius values into this general form. Likewise, your equation of C3 should look like that. Okay, so this is the hints for question 2 and 3, right? Try the rest of the questions yourself.